This is lesson 10.3, and this is about applying the Pythagorean theorem. In this lesson, we're going to use what we learned about special right triangles and what we learned about the Pythagorean theorem. So in this first exercise, I want you to look at these two boxes, and what you're really looking for is that diagonal, that red line that goes from the top left corner to the bottom right corner. So this is a cube, so it has lengths, width, and height all that are the same dimension, and we're just going to call that x. So you're looking for this diagonal. Again, it goes from the top left front of the box to the bottom right back of the box. So you can pause the video while you work, and then please unpause and I will walk you through the solution. So we're going to look at a couple triangles here. First of all, since this is a box, we know that those angles are right angles. So actually, let's look at this first triangle. And we can use this diagram on the right. So we know that the length and the width, or the two legs of the triangle, are both x. And we know that it's a right triangle. So we also know that those two angles are congruent, which makes this a 45, 45, 90-degree triangle. So we can use the 45, 45, 90-degree conjecture that we had in the last lesson to get that hypotenuse, which this hypotenuse happens to be the leg of that second triangle. So we don't know the angle measures of the second triangle, but we know that the height is x because it's a cube, and we just found the other leg. So now we're going to look for this hypotenuse of this new triangle, where one leg is x, the second leg is x times the square root of 2, and the hypotenuse is a. So now we're going to use the Pythagorean theorem. So we have x squared plus x times the square root of 2 squared, and that's equal to a squared. So x squared, and now we can use our properties of exponents. If you remember those from algebra, we have to distribute that squared to both terms inside our parentheses. So we end up with x squared times the square root of 2 squared, which is just 2, and that's equal to a squared. So just to simplify, we have x squared plus 2x squared, and that's equal to a squared. So x squared plus 2x squared is 3x squared. That's equal to a squared. And now in order to solve for a, we have to take the square root of both sides. And the square root of 3 times the square root of x squared. X squared is a perfect square inside our radical, so to simplify that, we end up with x times the square root of 3 is equal to a. All right, let's look at this example where we have actual dimensions, but this, if you notice, is not a cube. It's just a box or a rectangular prism. And so in this example, we're just going to round our answer to the nearest tenth. So again, we're looking for the diagonal of a box. What's the longest stick that's going to fit inside the box? The longest stick is going to be a diagonal. So we're going to focus on a couple different triangles. First of all, we're looking for the diagonal. Eventually, we're looking for the diagonal that goes from the bottom left front to the top right back. And really your diagonal could be anywhere on this diagram, just as long as it goes to the opposite corner. So we're going to draw a couple triangles in here. So first, let's look at this orange triangle. And again, since this is a box, we know this is a right triangle. We don't know the angle measures, so we can't use shortcuts, but we do know that both of these triangles that we're looking at, the orange one and the blue one, are right triangles. So let's focus on that orange triangle first. And we're going to use the Pythagorean theorem to solve for that hypotenuse of the orange triangle. So in this right triangle, one leg is 24, the other leg is 30, and we're looking for the hypotenuse, which we're going to call A. So 24 squared is 576, 30 squared is 900, that's equal to A squared. 576 plus 900 is 1476, that's equal to A squared. And then in order to solve for A, we take the square root of both sides. And again, we're rounding to the nearest tenth. So our A is approximately 38.4. Now we're going to focus on the blue triangle. So that A value, or 38.4, is now the leg of our blue triangle. And we're solving for the hypotenuse of the blue triangle in order to figure out how long the longest stick is that will fit inside the box. So our first leg, 38.4 squared, plus our second leg, which is 18, that's the height of the box, squared, is equal to d squared. 38.4 we know is 1476. And we're going to add 18 squared, which is 324, and that equals d squared. So 1800 is equal to d squared. So in order to find d, we need to take the square root of both sides. So d is approximately 42.4 inches. So that's how long the longest stick can be in order to fit inside this box. All right, now why don't you try one on your own? Now this one does not have a diagram, so your first step is going to be to draw a diagram. Now this is a box and the dimensions are 24 by 20 by 12. It does not matter where you put which dimension. So it doesn't really matter how you draw your box, you're going to come up with the same answer because we're going to look for that diagonal. So you can pause the video while you work and then unpause for the solution. First step is to draw your diagram. Again, it doesn't matter where you put which dimensions. Then your next step is to look at that base diagonal. So if your leg is 24, your other leg is 12, your diagonal of the base of the box is A, which we can estimate or we can round to about 26.83. Again, you might have used different dimensions when you drew your picture, and that's okay. At the end, you'll get the same answer. And then now you want to focus on that purple triangle that's drawn in. So your one leg is that hypotenuse of the orange triangle. That's one leg of your purple triangle. The height is 20, and then you're solving for the diagonal in order to figure out whether that 34-inch bat will fit. And your diagonal is only 33.47 inches, which is smaller than your 34-inch bat. So no, your bat is not going to fit in this box. It's a little over a half an inch too big. All right, here's another example. In this example, we're finding the perimeter of an equilateral triangle. Remember, an equilateral triangle is a triangle that has 3 congruent angles and 3 congruent sides. So in this example, we don't know what the side lengths are, but we know they're congruent, and we know all the angles are congruent. Now each of these angles is going to measure 60 degrees because in an equilateral triangle, they're all the same. A triangle totals up to 180 degrees. And then secondly, in any kind of isosceles triangle, which an equilateral triangle is a special isosceles triangle, the altitude is also the median, and it is also the angle bisector. So the median goes from the vertex to the midpoint of the opposite side, and it bisects the vertex angle, and it's perpendicular to the base. So we know that these two parts of the base are congruent because it goes to the median. Now all we know so far is that this median is 6 centimeters, but we don't know what any of the sides are. But since it's an equilateral triangle, we also know that it's a 30, 60, 90 degree triangle. So let's label what we know. Again, we know the height or the altitude of the triangle is the same as the median, which is 6 centimeters. And let's just think about that triangle on the right by itself for a second. So we know that this angle is 30 degrees because it's half of 60 degrees because it's the angle bisector. That median is the angle bisector. We know this other angle is 60 degrees because in an equilateral triangle, all angles are equal, which means they have to be 60 degrees because a triangle sums to 180. And then we know that this side length, this leg, is 6 centimeters. Now in a 30, 60, 90 degree triangle, we know that the side opposite of the 60 degree angle is the longer side. And we know that that's also equal to the shorter side times the square root of 3. So now we're going to use algebra to solve for A. So if the longer side is 6 centimeters, and that's also A times the square root of 3, to solve for A, we divide 6 by the square root of 3. And you can use a rounded answer for this, or you can leave it in exact form. I'm going to use a rounded answer. So that's approximately 3.46 centimeters. Now, in a 30, 60, 90 triangle, I also know that my hypotenuse is equal to 2 times the shorter side. So 2 times 3.46 is approximately equal to 6.92. or if you're using exact answers, 12 divided by the square root of 3. Now the question is to not find those sides, but the question is to find the perimeter of the equilateral triangle. So if I know that side C, that hypotenuse of that 30, 60, 90 degree triangle, if I know that that is approximately 6.92 centimeters, and it's an equilateral triangle, I know that all of the sides are 6.92 centimeters. So to find the perimeter, I'm going to multiply by 3 because there are 3 sides in this triangle, and the perimeter measures the distance around the polygon. So I get about 20.78 centimeters. All right, now let's look at this last one. And again, the first step here is to draw a diagram. So we're looking at a local community college. The area between the buildings is 120 meter by 120 meter square shaped grassy area. And we want to build a sidewalk for the students so they can cut across that grassy area. And we're going to build a sidewalk for them. So first we're going to draw our picture. So here's our 2 buildings. Here's our square grassy area. It's a square, so all the sides are congruent, and they all measure 120 meters. So what we're looking for is the diagonal of the square. That's where our sidewalk is going to go. So we can use the Pythagorean theorem to solve for this problem. But if you recognize that this is an isosceles right triangle because we're cutting a square in half, you can use that conjecture that we have for the 45, 45, 90 degree triangle, which says that the hypotenuse is equal to one of the legs, or the length of the leg, times the square root of 2. Now it's asking for you to round to the nearest meter, so you don't want to leave your answer in 120 times the square root of 2 meters. You want to round to the nearest meter, so you'll use your calculator to do that. So 120 times the square root of 2 is approximately 170, so that's how long our sidewalk will be. Now if you use the Pythagorean theorem, you're going to come up with the same answer. You just have to do a couple more steps. So 120 squared plus 120 squared is 14,400 plus 14,400. That's equal to c squared. So add those two together and you get 28,800. And then take the square root of both sides, which you get a c value of the same exact thing, 170 approximately. But that 45, 45, 90 will give you a little bit of a shortcut. So that's all for this video, so please jot down any questions or notes that you have, and we can discuss those when I see you in class. Thank you.